Welcome. In this video I'm talking about equivalent statements. So how will we know if two statements are equivalent? So equivalent compound statements are made up of the same simple statements and have the same corresponding truth values for all true-false combinations of these simple statements. So let me give you an example. The statement if P then Q, so that's the conditional if P then Q, is equivalent. This is the symbol that we'll use for equivalent. It's like an equal sign but with a third bar over it. Not Q implies not P. So let's show this to be true. So I'll need a truth table that involves P and Q. I need the conditional if P then Q. So true, true, false, false, true, false, true, false. These are all the possible combinations for my simple statements. Now, the if-then statement is false if the antecedent is true and the consequent is false. So that's here. And it's true otherwise. Now, I'm going to add a column for not Q, another one for not P, and then finally I'll need not Q implies not P. Okay, so I need to take the negation of Q. So this would be false, true, false, and true. And the negation of P will be false, false, true, and true. And here is the if-then statement. As again, an if-then is false when the antecedent is true and the consequent is false. So here's a case where the antecedent is true and the consequent is false. And in every other case, it's true. Now, look at the entries in this column and this column. And notice that they go true, false, true, true. They match. And so, in fact, these are equivalent statements. Let's look at, oh, by the way, I want to say, when you have a conditional statement of P implies Q, if P, then Q, I'm just going to make a note, this is the conditional. If you reverse the order and say that Q implies P, this is called the converse. So it just reverses the role of the antecedent and consequent. If I negate both but keep the same order, so if I said not P implies not Q, that's called the inverse. And if I do both, if I switch the roles and negate them both, so not Q implies not P, that's called the contrapositive. And notice that's what we were comparing to the original conditional statement here, and we found that these two statements are equivalent. And it turns out so are these. If I can show you that with a truth table. So true, true, false, false, true, false, true, false. And let's add in P implies Q. That is our true, false, true, true. Okay, so that's one we've done many times now. Let's look at the reverse when we say Q implies P. So remember, a conditional is true when the except in the case where this is true but this is false. So that happens here, that Q is true but P is false. So in this row the conditional is false, but everywhere else it's true. Now that's the converse. Now let's look at the inverse. So the inverse is where I say, before I construct the inverse, let's negate both P and Q. So not P and not Q. So this would be false, false, true, true, and this would be false, true, false, true. And now I can construct the inverse. Not P implies not Q. So this is a conditional. So I'm looking for the case where this is true but this is false, because that's where I'm going to put the false entry, and everywhere else I can be true. So here I have that combination where the first thing is true but the second is false. So I'll go ahead and fill in my F here, and then everything else is true. Now if I sorry about that. You couldn't see what I was doing there. Just to recap a little bit, here was the not P and not Q. This is the conditional. So what I want to point out is that the values here, true, true, false, true, match with the values here, true, true, false, true. So it turns out these two are also equivalent statements. All right, so let's say, for an example of some of these converse and inverse and contrapositive, if I didn't mean it, I wouldn't say it. So here I have two simple statements. So my P is I didn't mean it, and my Q statement would be I wouldn't say it. I wouldn't say it. So let's look at, and this is the statement, if P then Q. So first of all, let's consider if we take the converse. The converse just reverses positions and says if Q, then P. So if I didn't say it, I didn't mean it. And I think that you can see that's not equivalent here. You could just be silent and mean something. So that's not the same as if I didn't mean it, I wouldn't say it, or I didn't say it. All right, that's the converse. What about the inverse? So the inverse is when I'm going to negate P and negate Q, but I'm going to keep this is the antecedent and this is the consequent. So when I negate P, so that would mean if I mean it, or meant it, if I meant it, I would have said it. Notice I'm taking some liberty in the tense of my verbs just to make it sound more, what I want to say, more fluid or just more natural. So there's the converse and the inverse, and now let's form the contrapositive. So that's where I take not Q, if not Q, then not P. So I'm reversing the order and changing, making this, negating both. Now, both of these statements involve not. So to negate them, I can just drop that and say if I said it, so that's the negation, I wouldn't say it, I said it. If I said it, I meant it. So, and that's taking the negation up here. So it's these two are saying the same thing. They are equivalent. And these two are equivalent, the converse and the inverse. All right, I hope that helps with your understanding of different, what equivalent statements are, and also how we can take a conditional and then form the converse. Oops, this should be converse, inverse, and contrapositive. See you next time.